Hello everyone, my name is Yogendra Ranma. Today we are going to learn about the topic formal charge. In this topic we will be trying to learn about the charge assigned to each atom in the molecule. So without wasting lot of time, let's get into the topic. So uh, you can see here the topic name formal charge, right? So what is formal charge? Formal charge is nothing but the charge assigned to the atom in a molecule. Charge assigned to the atom in a molecule. So let us say you have taken a molecule. Let it be hydrogen, H2O molecule. So there will be a charge that is assigned to each atom, like hydrogen atom and oxygen atom that are present in the uh, water molecule, and there will be a charge assigned to each atom in the molecule. It is nothing but as formal charge. Is this formal charge real or fake? Actually, this formal charge is fake. That's why it is also called as fake charge. It is also called as fake charge. Okay. So what is formal charge? It is the charge assigned to an atom. It is the form charge assigned to an atom in a molecule, right? Now, let us try to understand using an example what is this formal charge is. Let us read the question here. The question is, what is the formal charge of sulfur in S442 minus ion, right? So, and the second question is, what is the formal charge of oxygen in S442 minus ion? So, to solve this question, we need to know a formula which is very helpful for us to find out the formal charge of the respective atom in the molecule, right? Okay, now we will try to learn the charge formula that is required to solve this question. So I'm going to teach a trick through which we can solve this formal charge. Okay. So the trick is to remember this trick. I'm going to give you a mnemonic which will be very helpful for us to remember. Okay. The mnemonic for today is VBD. So you are all very much familiar about the cricketer, international cricketer AB de Villiers, right? So simply we call him as ABD. So here you are going to change. We are changing it as VBD for our sake of convenience to learn this formal charge. Okay. So FC is equals to VBD. What is V stands for? V is valence electrons. V is nothing but valence electrons. So we all know that uh, the number of valence electrons if we have the idea of periodic table, right? So B stands for total number of bonds. B stands for bonds and D stands for dots. D stands for dots. Okay. So to solve this question, we need to write the structure of the molecule in Lewis dot structure. If you don't know how to write Lewis dot structure, soon I am going to make a video on that. You can refer that. Okay, so we have to subtract V minus B minus D. When we subtract the bonds and dots from the valence electrons, we will get the formal charge on the atom, right? Okay, this is the formula to find out the formal charge. Now, let us get into the question. What is the formal charge of sulfur in SO4 2 minus? So here we have drawn the structure of SO4 2 minus ion. So there is no need to draw the structure. We will look into it later. And now, for now, we will be finding out the formal charge of sulfur. So formal charge of sulfur is, what is the valency of sulfur? Valence of sulfur. Sulfur comes in the group of oxygen. Okay, so oxygen's valency is 6. So sulfur's valency is also 6. Yeah, so sulfur's valency is 6. And what are the bonds that are present? How many number of bonds that are present around the sulfur here? 1, 2, 3, 4, 5, 6, right? So there are totally 6 bonds that are present over around sulfur atom. Now, when we see the dots around the sulfur here, is there any dots that are present around sulfur here? Absolutely, there are no dots, right? So we are going to subtract 0 dots from it. So 6 minus 6 is what? Is 0. So what we can say is the formal charge of sulfur in SO4 2 minus is 0. Now comes when we see here the oxygens that are present around sulfur atom, there are two types of oxygens here. Let us first of all number these oxygen atoms 1, 2, 3, and 4. When you see here, the oxygen 1 and oxygen 3 are one and the same, like they are equivalent. Then when we see the oxygens 2 and oxygen 4, they are also equivalent. So oxygen 1 is equivalent to oxygen 3 and oxygen 2 is equivalent to oxygen 4, right? So if you find the formal charge of oxygen 1, it will be the formal charge of oxygen 3 is also same. And if you find the formal charge of 2, it will the oxygen 4 also will be having the same formal charge as oxygen 2. Okay. Now let us find the formal charge of oxygen 1. So here when we see the oxygen, what is the valence of oxygen? It is 6. Okay. Then the total number of bonds that are present around the oxygen atom is what? 1, 2. Okay. The total number of bonds that are present around oxygen is 2. And now we have to look about the dots present around this oxygen atom, right? So 1, 2, 3, 4. So there are totally 4 atoms 4 dots, sorry, there are 4 dots that are present around this oxygen atom. So we are going to write 4 here. So 6 minus 2 is 4. 4 minus 4 is 0. So the formal charge that is present on this oxygen atom as well as this oxygen atom is 0. Okay. Now we are going to find the formal charge on oxygen 2. If you find oxygen formal charge on oxygen 2, it will be same as that is on oxygen 4 as well, right? So first of all, we have to think of valency of oxygen atom, right? So 6 is the valency of oxygen. We all very much aware. We have solved this in the case of oxygen 1 also. So 6 is the valency of oxygen, and then we have to subtract the number of bonds that are around this oxygen atom. So when we check this oxygen 2, how many bonds are there? Here is the only bond that is present around in and around the oxygen 1, right? So we are going to write the same 1, and we have to subtract the number of dots that are present around this oxygen atom. Dots are nothing but electrons, right? So you are very much aware that there are totally 1, 2, 3, 4, 5, 6, 6 dots that are present around the oxygen 2, right? So 6 minus 6 is 6 minus 1 is 5. 5 minus 6 is minus 1. So the formal charge of oxygen 2 here is minus 1. So in the same way, the charge on this oxygen atom also same, right? So because they are equivalent oxygen atoms. So the formal charge on this oxygen atom is also minus 1. So here this is having minus 1 charge, and this oxygen is giving minus 1 charge. We have seen that the sulfur atom has 0 formal charge here. It gives 0 formal charge, and the first and third oxygen atoms are also giving 0 formal charge. So they don't contribute any formal charge for the molecule. So the only atoms that are contributing for the formal charge is this 0 minus, this oxygen atom and this oxygen atom. The oxygen 2 and 4 are contributing the formal charge of this SO4 2 minus atom. So this is contributing minus 1 and this is contributing minus 1. This oxygen atom is contributing minus 1. So the total charge on this SO4 2 minus is 2. So where is this 2 minus is coming from? So here you would get idea that the 2 minus is coming from here, minus 1 here and minus 1 here. This is contributing, so the total charge on the SO4 minus ion is 2 minus. Now, so I believe that everything is very clear for you. So now let's go into another example. Let us solve another. Now let us solve another example here. So we all very well know that formal charge is nothing but V minus B minus D. We all know ABD, so we are changing it as VBD. That's all. There is no more changes. And now we have to let's find out the formal charge. The first question is what is the formal charge of carbon in methanol, right? So this is the structure of methanol in Lewis dot structure. This is the Lewis dot structure of methanol. So now we are going to find out formal charge of carbon. Okay, what is the valency of carbon? I am very much sure that you all know uh, the valency of carbon atom. So it is nothing but 4. Then what is the total number of bonds that are present around carbon atom? You can see here, right? What are the total number of bonds that are present around carbon atom? 1, 2, 3, 4. So there are totally 4 number of bonds that are present around carbon atom. So what are the total number of dots that are present around carbon? If you can see here, there is no dot that is present around carbon atom here. So it is going to be 0. So what is 4 minus 4? 4 minus 4 is nothing but 0. So the formal charge of carbon in methanol is 0. Okay. Then comes the second question, which is what is the formal charge of oxygen in methanol? So formal charge of oxygen in methanol. Now we are going to calculate formal charge of oxygen in methanol. So if you can see here, the formula, what is the valence of oxygen in the previous molecule also, we have seen the oxygen of methanol is, if you can remember, the valence of oxygen is 6. Now we have to subtract the total number of bonds that are present around oxygen here. So here is one bond, here is the another bond, right? So what is the total number of bonds that are present around oxygen? It is 2. And now what are the total number of dots that are present around oxygen? If you can see here, 1, 2, 3, 4. There are total of 4 dots that are present around oxygen. So when we solve this, 6 minus 2 is 4, 4 minus 4 is 0. So the formal charge of oxygen in methanol is 0. Now let's find out the formal charge of hydrogen, because the question says we have to find out the formal charge of hydrogen in methanol. Right. So here comes. So when we see what is the valency of hydrogen, valency of hydrogen is 1, right? And now we have to subtract the total number of bonds that hydrogen is attached to. So here is only one bond that is present. This is the only one bond that hydrogen has. So we are going to subtract that bond. So 1 minus 1. Now we have to subtract the total number of dots that are present around hydrogen. If you can see here, there is no dot that is present around hydrogen, right? So the total number of dots that are present around hydrogen are 0. 1 minus 1 is 0. So we can conclude that the formal charge on carbon is 0, and on oxygen, oxygen and hydrogen are also 0. So the total formal charge that is present on the methanol is finally 0, right? So I'm giving a exam homework. So let us consider there is a BCl3 molecule. Its Lewis dot structure is given as this: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now your responsibility is to find out the formal charge on this boron atom and this chlorine atoms. There are 3 chlorine atoms, and you have to find out the formal charge on all these 3 chlorine atoms. The hint that I am giving for you to solve this example is that all the 3 chlorine atoms are equivalent. You can now take out the concept that we have just used in the solving SO4 2 minus ion, and then you can happily easily solve this question. So thank you for watching. We will meet you soon.